All right, welcome to tonight's video on rational algebraic expressions. A rational expression is a quotient of polynomials. And an example here, we're going to simplify a rational expression. 5a squared plus 4a minus 1 over 5a squared minus 10a minus 15. The first thing you want to do is factor the numerator and denominator completely. So 5a squared plus 4a minus 1 factors. You multiply by negative first and last. What are the factors of negative 5 that add to 4? They are 5 and negative 1. So remember, you're going to go 5a plus 5, 5a minus 1. Then you factor out the common factor, divide by the GCF. In this case, you divide by 5, so you get a plus 1. And this one does not have a GCF other than 1, so you just leave it. So on the top, you have a plus 1 over 5a minus 1 in the numerator. The denominator, you have 5a squared minus 10a minus 15. Factor out the GCF first, so you get a squared minus 2a minus 3. The factors of negative 3 that add to negative 2 are negative 3 and positive 1. So there are the factors of the denominator. Then then you determine the restrictions on the denominator. Remember, that basically means what makes the denominator equal to 0. So in this case, a cannot equal 3 or negative 1, because those two numbers would make the denominator equal to 0. Then you're going to cancel out any common factors from the numerator and denominator. So notice they both have an a plus 1. So you're left with 5a minus 1 over 5 times a minus 3. And that a cannot equal 3 or negative 1. That's your final answer. All right, next one. When you raise something to negative first power, that means it goes to the bottom of the fraction. So you have z to the fourth minus 5z to the third plus 6z squared over 9z minus z to the third. So you factor out a common factor of z squared. So it's z squared minus 5z plus 6 over, in this case, factor out a z, so it's 9 minus z squared. Factoring the numerator, the factors of 6 that add to negative 5 are z minus 3 and z and negative 2, so it's z minus 3, z minus 2. And then here it's a difference of two squares, so it's 3 minus z and 3 plus z. So then you are going to look to see what z cannot equal. In this case, z cannot equal 3 or negative 3 or 0, because those would make 0 would make z equal 0, 3 would make that, and negative 3 would make that. Cancel out what they have in common. Well, they don't have something exactly in common, but remember, if it's 1 minus 3, it's negative 2, and 3 minus 1 is positive 2. So if it's a subtraction problem but in a different order, you can cancel them, but they're the opposite, so you have to leave a negative 1 on one of the factors. And then here you can cancel the z and just make that a 1. So you have negative z times z minus 2 on the top, and then 3 plus z on the bottom, or z plus 3. And those are your restrictions. All right, for this example here, you factor out 2x from the top, and you get 4x minus 3 over 4x squared. when you cancel 2 zeros into 4 twice, and x, you can cancel an x there, so it's 4x minus 3 over 2x, and x cannot equal 0, because 0 would make the x there equal to 0. Factoring out the top here, x times, it gives you x, and then parentheses x squared plus 6x plus 9 over, and then you factor out an x here, and you get x squared minus 9. When you factor the bottom here, you get x minus 3, x plus 3, because it's a difference of two squares. And then on the top, it's x plus 3 and x plus 3, because the factors of 9 that add to 6 are 3 and 3. That means for your restrictions that x cannot equal 0, because that would make x equal 0, 3 or negative 3. And then you can cross off the x plus 3's and the x's, so you're left with x plus 3 over x minus 3. Here, notice one's x minus 3, the other's 3 minus x, so you can cancel those, and then one's the opposite, so it's equal to negative 1. The restriction, you could not put 3 in the denominator, so x cannot equal 3. The last one here, this is y minus 2 times y minus 2. And then y squared minus 4 is the difference of two squares, so y minus 2 and y plus 2. That means the restrictions are that y cannot equal 2 or negative 2, because that would make the denominator equal 0. Cross out one of the y minus 2's, so you get y minus 2 over y plus 2 with those restrictions. All right, hope this has helped, and I hope you have a good evening. Oh shoot, did I not finish that?